Welcome to this second part of the video series, Which Way is Smart? Helping you to know which direction to take. This is part 2 in the series Which Way is Smart and deals with the smart topology and the components within it, such as meters, headend system, concentrator and MDM. As I've said before, it's important to keep a sense of humor. As Groucho Marx once said, if you've heard this story before, don't stop me because I'd like to hear it again. In our smart topology, we're first of all going to look at the smart meters. These are a significant capital investment, and so it's essential to choose meters which are fit for purpose. We'll also investigate what we exactly mean by a smart meter and whether it applies to the traditional STS prepayment meters as well. As the signpost shows, STS meters come in different forms as well: integrated, PLC, DIN rail, split meters, or with a separate CIU. Scotty from Star Trek would tell us,
"These are very sensitive instruments."
So first of all, let's explore STS meters. Now, STS meters are not traditionally viewed as being smart because of their offline limitation. Their offline nature has proved challenging in respect of detecting consumer fraud, because once a meter is installed in the field, it effectively becomes invisible. You have to go and inspect it to see if it's still working and hasn't been bypassed. In spite of this, however, STS prepayment meters are very popular because of their low cost and because they're standardized technology, so you can buy from different manufacturers knowing that they are interoperable with your vending system. There are, however, exciting new ways to enable STS meters with bidirectional communication. See, for example, the Smart STS video on this YouTube channel. So although we wouldn't traditionally think of STS meters as being smart, by using a product such as Smart STS, we can enable bidirectional communication with those meters, and in effect, they can become smart. In terms of the different types of STS meters, originally there was only the integrated meter, which contained the metrology and the user interface. However, the drive towards modularization has facilitated a distributed metrology, such as split meters, where the customer interface and metering parts of the meter are housed separately. Split meters that use PLC, that means power line communication, to communicate between the meter components are an excellent innovation, but they can be problematic in some older electrical installations. The introduction of split meters has gone a long way to reduce fraud aspects, so in terms of STS, split meters seems to be the way to go. While, as I have explained, it is possible to enable STS meters to become smart, it isn't typically what we would associate by a smart meter. For higher end, typically commercial and industrial consumers, they usually have more demanding needs, and so more appropriate metrology is required in the form of these smart meters, and they have bidirectional communication, the ability to measure a wide variety of readings, they can be remotely controlled and configured, and they support measurements for more complex tariffs, such as time of use tariffs. However, increased functionality comes with a higher cost of ownership. The cost and reliability of communication with those kind of smart meters for those high-end customers is incredibly important, because the service level agreements with those customers are often quite considerable, and this challenge is often overlooked by the utilities. Casting our minds back to the first part of this video series, we want to evaluate a smart metering topology at the metering level based on, first of all, communication. Communication can be costly, so it's often very useful to reduce costs via local communication or wired communication to a concentrator. It's also important to consider the collaborative effects of the components. Ideally, meters from different manufacturers should be able to be used with the same concentrator. This is essential for operational support and maintenance, because you wouldn't want to replace one meter in a cabinet with a different manufacturer's meter, and now it won't integrate with the concentrator in that cabinet. We also need to consider the information that needs to be gathered from those meters. How will it be measured? What will we be needing? And ultimately, what data will we use? There's no point in collecting data that will never be used. And finally, another important consideration, of course, is the costs. Do the costs support the business case? In other words, the cost of the whole meter, concentrator and communication, will it be supported by the revenue that is going to be received by the customers at those endpoints? Concentrators act as intermediaries between a headend system and meters. They gather reading information from meters in the local vicinity and then send those on to the headend system at the appropriate times. Similarly, they receive commands and controls from the headend system and then distribute those to the meters in the local vicinity. Concentrators play a very important part in easing the load of the headend system. Concentrators come in many different forms. It's possible to put the concentrator logic inside a modem, for example. Another good option is a Raspberry Pi. A meter can also act in a concentrator mode when it has submeters beneath it. And of course there are many different bespoke examples as well. Using concentrators is a good way to reduce overall capital and operational cost per meter, because the hub and the communication device associated with the hub can be shared across multiple locally connected meters. Ensure that the concentrator, however, is able to multitask to allow simultaneous execution of readings and commands. For example, if you need a reading taken by every single meter that's connected to a concentrator at the exact time, then that concentrator must be able to multitask that activity. Insist on interoperability so that one concentrator can support meters from different manufacturers. I can't emphasize this enough. Imagine if you have one set of meters only in a particular cabinet and you can't replace a faulty one with a different manufacturer because that meter can't connect to that concentrator. The ability to upgrade firmware is also very important because comms and methodologies change and new use cases are added, so it must be possible to update the firmware inside the concentrator. Give preferences to concentrators which support multiple communication mediums as well to the headend system. So for example, the concentrator might have a primary communication medium of GSM and supported by a secondary communication medium of Wi-Fi. Another alternative is a primary medium of LPWAN supported by a secondary medium of GSM. Using concentrators must, however, make business sense. The third component in our AMI hierarchy is the headend system, or HES. It is responsible for communicating messages from the MDM down to meters or concentrators and receiving readings and events back from those concentrators and meters to the MDM. It is not a data repository. That is the job of the MDM. It is actually responsible for communication. Don't let that fool you though, because flexibility with the headend system is absolutely paramount. It should use an interoperable data format and communication standard, such as the SIM objects. You need it to be extremely efficient so that it has the ability to communicate with the different meters during a 24-hour period. You should consider whether it's going to be hosted by a third party or hosted in-house. And of course, performance and scalability are absolutely vital. By performance, I mean the ability to do what it needs to do quickly and efficiently. By scalable, I mean that the headend system will be able to support many more endpoints than you currently have in your system. Finally, because in many cases the headend system is communicating by a wireless network, you need to consider the aspects of security so that the data between the meter and the MDM is secured. The headend system is the workhorse. As I have mentioned, where possible, use a flexible headend system which supports open communications to avoid having multiple headend systems. You think not? Yes, you'd be surprised. Be cautious the choice of headend system doesn't inadvertently limit your choice of concentrators and vice versa. As I've mentioned, verify the scalability and performance to support your growing meter base. Multitasking meter concentrator communications is basically non-negotiable. And then avoid the temptation to gather as much metrological data as possible. Collect only what data you really need, and ensure that the headend system is also able to distribute firmware upgrades to the concentrators and possibly meters as well. Elmer Fudd knows when something's not right.
There's something screwy around here.
Could be you, Doc.
finally we come to the last component in the AMI hierarchy, which is the Meter Data Manager, or MDM. This is home base for all your metrological data. Many of the same aspects that applied to the headend system also apply to the Meter Data Manager. You need to have an open system, it needs to facilitate easy integration, and for that the IEC 619689 standard is a very good one based on SIM. You need to be aware whether you're going to host it yourself or you're going to have a third party host it, perhaps in the cloud. And once again, performance and scalability are very important. In this case, however, the performance and scalability particularly pertain to the amount of data that the MDM is going to be expected to be storing and to be able to retrieve in a timeous manner. And then, of course, the data inside the MDM needs to be secure. So as I have mentioned, the MDM is the grand central station for your metadata. Use a flexible MDM which supports an international standard, as I've mentioned, such as IEC 619689, and be cautious, however, that the choice of MDM does not also inadvertently limit your choice of headend system and vice versa. You might find that certain manufacturers will promote a particular headend system and MDM together, and they might not actually work with those supplied by other manufacturers. If you're not careful, you may end up with multiple MDMs. Can you imagine that? We know what Spock would think about that.
That, sir, is illogical.
Verify scalability and performance to support your growing meter base, and in particular, understand how your data storage needs will grow and be managed. Can't emphasize that enough. And again, avoid the temptation to gather too much metrological data and only record what you need. I have mentioned this throughout this video, but I'm just going to say it again. Interoperability needs to be the watchword. You'd be amazed, but meter types may not be interchangeable with concentrator types. Concentrators might not be interchangeable with headend systems, and headend systems might not be interoperable with MDMs. But isn't interoperability one of the main reasons for going smart? Yes, but as Shakespeare said in Hamlet, it's more honored in the breach than the observance. This completes the second in our set of videos on which way is smart, and now we're going to move on to the topic of smart communications.